lesson on or about Module 6 of the second quarter. This lesson, as we know, is entitled Simplifying Radicals by Removing Perfect Nth Powers. For purposes of clarifying the examples, let me show to you how each of the illustrative examples are simplified. As you can see, the direction is express each radical in simplest form. Now, let us go to the first example. We have simplify the sixth root of x to the power 17. Now, we have to factor x to the power 17 such that one factor is a perfect sixth power. Now, actually, 17 or x to the power 17 can be factored as x to the power 6 times x to the power 11 or x to the power 12 times x to the power 5. But we go for the second pair of factors because the exponent of x12 is much higher than 6. So here we go. The sixth root of x to the power 12 times x to the power 5. We choose 12 because 12 is exactly divisible by 6. And we choose 5 because 5 is lower than 6. Now, x to the power 12 could be simplified this way. So we have sixth root of x squared to the power 6. This is the simplified form of x to the power 12. Why choose 2 and 6? It's because 2 times 6 is 12 and 6 is equal to the index 6 here. So we have times x to the power 5. So the sixth root of x squared to the sixth power is of course x squared. So we take out x squared outside the radical. So this will now be x squared, then the sixth root of x to the power 5. Again, we choose 2 and 6 or 2 times 6 as the exponent of x because 2 times 6 or 12 divided by 6 is 2. So we have x squared raised to the power 6 times x to the power 5. Since the exponent of x squared or the power of x squared x of 6 is equal to the index, we cancel 6. So we take out x squared and write it as coefficient of the sixth root of x to the fifth power. Take note that x squared is no longer written inside the radical because the exponent or the power of x squared 6 is equal to the index 6. So the simplified form is x squared sixth root of x to the power 5. Let's proceed to number 2. Number 2 is simplify the fourth root of 64 to the a to the power 11 c to the power 24. Now 11 is not divisible by 4, so meaning it's not a perfect fourth power. But this this 11 could be the sum of 8 and 3. So we go for 8 and 3 as exponent of a, or 8 plus 3, because 8 is divisible by 4. 64 on the other hand is not a fourth power. However, we have the fourth root of 64 could be written as 2 to the power 4 times 2 to the power 6. 2 to the power 2. Why? Because 2 to the fourth power is 16. 2 to the second power is 4. 16 times 4 is 64. Then 11 could be written as a to the power 8 times a to the power 3. C to the power 24 is a perfect fourth power because 24 is divisible by 4. So this can be written as C to the power 6 raised to the fourth power. So we cancel, or we have here 4 divided by 4 is 1, so write 2 outside. So we cancel this. 2 squared is not a perfect fourth power, so we write it separately. We have the fourth root of 2 squared. Then 8 to the power 8, we have 8 divided by 4 is 2. So the fourth root of 8 to the power 8 is a squared. Again, because 8 divided by 4 is 2. A cube is not a perfect fourth power because 3 is not divisible by 4 and 3 is lesser than 4. We write it here, a to the third power. Then c to the power 6 raised to the fourth power. We have, this is actually 24 now, divided by 4, 6. So we have c to the power 6. So the simplified form of the fourth root of 64, a to the power 11, c to the power 24 is 2a squared, c to the 6th fourth root of 2 squared, a cubed. However, 2 squared is 4. So the final answer is 2 a squared c to the power 6 fourth root of 4 a cube. So this is the final answer. Let's proceed to number 3. Our number 3 is simplify the fifth root of x squared plus 2 raised to the power 5. Now, this is a radical form. Now, if we apply the laws of, or the procedure, the correct procedure in writing radicals as expressions with rational exponent, take note, our base here is quantity x squared plus 2. X squared plus 2. Then the exponent of the radicand is 5, this one. So we have to the power 5 over the index is 5. So over 5. So the radical, the fifth root of x squared plus 2, quantity raised to the fifth power, is equal to the quantity x squared plus 2 raised to the 5, this one, over 5, the index. Since 5 divided by 5 is equal to 1, our final answer would be x squared plus 2. Yay. Here, we go to number 4. Our number 4 is the cube root of x cubed plus y cubed. Now take note that this cannot be simplified. Okay, this cannot be simplified simply because x cubed plus y cubed is not equal to quantity x plus y raised to the third power. So cube root of x cubed plus y cubed is already in the simplest form, cannot be simplified anymore. For number 5, we have the sixth root of 18 to the power 50. 50 is the sum of 48 and 2. Why choose 48 and 2? Because 48 is the highest multiple of 6. So, here we go. This is equal to the sixth root of 18 to the power 48 times 18 to the power 2. Because 48 plus 2 is equal to 50. Then this is 48 divided by 6 is actually equal to 8. So, this is sixth root of 18 to the power 8 raised to the power 6 times 18 squared. Since the power of 18 to the power 8 is 6, and 6 is equal to the index, so we cancel this one. So we write outside the radical 18 to the power 8, and what remains as radical is the sixth root of 18 squared. Since 18 squared is equal to, okay, excuse me, let's proceed. So this is 18 to the power of 8 means 18 is used as a factor 8 times. So this is 18 to the power 8. So is 11 billion 19 million 960,576. What remains under the radical sign is 6th root of 18 squared. However, we apply the laws on simplifying radicals, so this may be rewritten as the cube root of the square root of 18 squared. The index of 18 squared is understood 2, so equal to the exponent. So we cancel this one and remove this radical sign inside. So the final answer is 11 billion 19,960,576 cube root of 18. This is as far as lesson 1 is concerned. Let's go to the examples of lesson 2. Our lesson 2 focuses on simplifying radicals by reducing the index to the lowest possible order. Reducing the index to the lowest possible order. Now, we go to the first example. This is actually for lesson 2. Our first example is simplify the fourth root of 64. Okay. Now, 4 can be factored to 2 times 2. So, this means that the fourth root of 64 may be written as the square root of the square root of 64. Why? Because the index here is understood 2, index here is also understood 2, 2 times 2 is 4. So the fourth root of 64 is equivalent to the square root of the square root of 64. Now 64 is a perfect square. So it means that this is equal to the square root of 8 squared. Now as we know, this is 2. This is also 2. Now the exponent of x, which is 2, is equal to the index. So we cancel this one. So our final answer is the square root of 8. Take note, this radical sign is already removed because the index 2 is equal to the exponent of radicand, which this one, 2. But the square root of 8 is not yet simplified because 8 contains a perfect square factor, 4. So we simplify. Square root of 8 into square root of 4 times 2. 4 is a perfect square. The exponent of 4 is 2, so this simplifies to 2 square root of 2. However, before reaching to that final answer, we can have this. 4 may be written first as 2 squared. So 4 times 2 becomes 2 squared times 2. The index again here, when there is no index, the index is understood 2 here, understood 2, this is understood 2. So we cancel this because 2 divided by 2 is 1, so outside the radical symbol or sign, radical expression, or the radical is now 2, this one. What remains under the radical or as a radical is square root of 2. So 2 square root of 2 is in simplest form already because the index is now reduced to the lowest possible order. From 4, the index is reduced to just 2 here. So number 2, simplify. The sixth root of 16x to the power 6. So we have 16, as we know, is a perfect square. Since it is a perfect square, we can factor 6 into 3 times 2. 3 times 2. So we have the cube root of the square root of 4 squared. 16 is written as 4 squared, so that the exponent 2 would be equal to the index here, understood 2. Then x to the power 6 may be written as x cubed squared. Reason, so that the exponent 2 becomes equal to the index. So we have to cancel this one, cancel this. So both 4 and x cubed should now be written outside this radical. So in other words, the inner radical symbol will now be removed. So we have the cube root of, since this is equal to the index, so this is outside this one, and equal to the index 2, so outside. So there is no more inner radical. So the cube root of 4 x cubed. However, we have here the exponent 3 is equal to the index, so we cancel this again. So x is now written outside. So x, what remains as radical is cube root of 4. So this is our final answer, x cube root of 4. We go to number 3. We have here the 20th root of 32 n to the power 15 n to the power 5. As you can see, 32 is a fourth power. Fourth? No, 32 is factorable to 16 times 2. 16 is a perfect fourth power. So we can proceed as follows. We have, so again, I'm sorry. 32 is the fifth power of 2. 2 to the fifth power is 32. And the 15th is also a fifth power because 15 is divisible by 5. And to the fifth power is another fifth power, perfect nth power, fifth power, because 5 divided by 5 is equal to 1. So you factor the index 20 into 4 times 5. 4 will be our outer index and 5 is the inner index. So we have fourth root or the fifth root of 32 is 5, 2, not 5, 2 to the power 5, then n to the power 15, n to the power 5. So this is the fourth root of, cancel 5, so we have 2. 15 divided by 5 is 3, so we have m cubed. 5 divided by 5 is 1, so we have n. So fourth root of 2m cubed n is the simplest form of number 3. Let's now proceed to lesson 3. Lesson 3. Lesson 3 is on simplifying radicals by rationalizing the denominator. So this is our lesson 3. For the first example of lesson 3, we have number 1 is simplify the cube root of 13 over 2. Okay, how to do it? Have the index here is 3. 2 is understood to have 1 as exponent. So what should we do so that the index 2 becomes a perfect third power? Remember, 2 is understood to have an exponent of 1. To make 2 to the first power a perfect third power or 2 cube, we multiply both the numerator and the denominator by 2 squared. So we proceed as follows. The cube root of 13 over 2 times 2 squared over 2 squared. So this is equal to the cube root of 13 times 2 squared is 4 over the understood exponent of 2 is 1. When multiplying powers of the same base, our base here is 2. Here 2 also. We copy the base 2 and add the exponents. 1 plus 2, we have 3. Now, you can see that the exponent of the denominator is now 3. This is equal to the index. 2 cubed is a perfect third power, and so 2 may be now removed from this radical. So what remains in the radical will be the cube root of 13 times 4 is 52. And over, since 3 divided by 3 is 1, over 2 to the power 1 or 2. So in short, cube root of 52 over 2 is the final answer. The simplest form of the cube root of the square root of 13 over 2. We go to number 2. Number 2 is simplify. The fourth root of 9a cubed y squared over 8b to the power 6 x cubed. Okay. Now, the denominator is 8b to the 6th x cubed. Now, 8 is actually 2 cubed. Again, 8 is equal to 2 cubed. What shall we multiply with 2 cubed so that it becomes a perfect fourth power? Of course, 2. Because 8, which is 2 cubed times 2, is 2 to the fourth power. The exponent of 2 to the fourth power is 4, which is equal now to the index. b to the sixth power is not a perfect fourth power, but it contains a factor which is a perfect fourth power, b to the fourth power. Okay? So, to make b to the sixth a perfect fourth power, we multiply this by b squared. For x cubed, we multiply x cubed by x, so that the result becomes x to the fourth power whose exponent is equal to the index 4. So, our first step is multiply both numerator and denominator by 2b squared x. So, here we go. The fourth root of 9a cubed y squared over 2 cubed, that is 8. b to the 6th x cubed times, we have, sorry, this is 2 cubed because this is equal to 8 times 2, then b squared, because b squared times b to the 6 is b to the 8th, then x, because x times x squared is x to the 4th, over the same is multiplied to the denominator, 2b squared x. Now the fourth root of, multiply the numerators. 9 times 2 is 18. A cubed, copied, then b squared, copied, x, copied, y squared. Again, we have, to avoid confusion, we arrange the variables in alphabetical order. So we have 9 times 2, these are the numerical coefficients, so we have 18. The a cubed is copied because there's no other expression here, which is with a base of a, so copy. Then b squared, copied. X, then y squared also copied because there's no a in here, there's no y in here. So, they are just copied. Over 2 cubed times 2, understood 1 is 2 to the 4th power. B to the 6 times b squared, copy the base b, so you have b to the power, add exponent, 6 plus 2 is 4. Then x to the power, copy the base here, then add exponents, 3 plus understood 1 is 4. So this is equal to the 4th root of 18 a cubed b squared x y squared over, take note that we are removing 2bx from the radical. Why? Because the exponents, or these are perfect cubes. So I committed a mistake here. B to the power 6 times b to the power 2 is actually b to the power 8. So I stand corrected. This is b to the power 8. So over. Cancel this being equal to the index because 4 divided by 4 is 1. So we have 2. B to the power 8. The exponent b, the 4th root of b to the power 8. 8 divided by 4 is 2. So this becomes b squared outside the radical already. X to the 4th power exponent 4 is equal to the index. So cancel this one. So we have, this is already 4. This is 2, 4 divided by 4, 1. So we have x. So our simplified form is the 4th root of 18a cubed b squared x y squared over 2b squared x. So this is the simplified form. We go to another set of examples. This set of examples still falls within lesson 3, but as you can see, the denominators are binomials. Let's go to the first example. We have simplify 4 over x plus square root of 3. X plus square root of 3 is a binomial involving a radical. The radical here is square root of 3. These two terms, x and square root of 3, are connected with a plus sign, or by a plus sign rather. Now, if we change this plus sign to minus sign, this becomes x minus square root of 3. X minus square root of 3 is now called the conjugate of the denominator. So our first step is determine the conjugate of the denominator. Our conjugate of the denominator is simply obtained by changing the sign between the two terms. So positive here becomes negative. So the conjugate of the denominator is x minus square root of 3 again. X minus square root of 3 is the conjugate of the denominator, x plus square root of 3. So now we proceed to multiplication. We multiply the conjugate of the denominator. So we have 4 over x plus square root of 3 times x minus square root of 3 over x minus square root of 3. Take note that the conjugate of the denominator is multiplied to both numerator and denominator. Why? Because x minus square root of 3 over x minus square root of 3 is equal to 1. And 4 divided by x plus square root of 3 times 1 is the same. 4 over x plus square root of 3. We are only changing the form, but we are not changing the value. That's why we are seeing to it that this expression, the multiplier, is equal to 1. Any quantity, as a matter of fact, multiplied or divided by itself is equal to 1. So, we multiply 4 and x minus square root of 3 by distributive property. First, 4 times x is 4x. Then, 4 times negative 3 is negative 4 square root of 3. For the denominators, we apply the FOIL method. F stands for the first terms, O for the outer terms, I for the inner terms, and L for the last terms. Our F, or first terms, would be x times x squared. Outer terms, x times negative 3. We have negative x square root of 3. The inner terms, positive square root of 3 and x. Positive square root of 3 times x is positive x square root of 3. And for L, the last terms, square root of 3, positive square root of 3 times negative square root of 3 is negative square root of 9. So, 4x minus 4 square root of 3 over, we have to copy x squared. There's no other term here containing x squared, so we copy x squared. Then, positive x square root of 3 and negative x square root of 3, they are additive inverses, which means that if they are added, the result is 0. So we cancel this because positive or negative x square root of 3 is the additive inverse of x square root of 3. Take note that if a quantity is added to its additive inverse, the result is 0. That's why we have to cancel negative x squared of 3 and positive x squared of 3. So what's left is 10 negative square root of 9. The square root of 9 is 3, so we have minus 3. So, we cannot factor x squared minus 3 anymore. 4x minus 4 square root of 3, although this can be factored, okay? Although this can be factored, since this can be factored, we try to write this one into, the common nominal factor is 4, so 4x divided by 4 is x. Negative 4x, negative 4 square root of 3 divided by 4 is the negative square root of 3. So we have 4 times x minus square root of 3 over x squared minus 3. Okay? So this expression, this one, is the simplest form of 4 over x plus square root of 3. Okay, so we go to example number 2. Example number 2 is simplify 3 square root of 6 minus 4 square root of 3 over 4 square root of 6 minus 2 square root of 3. Again, simplify 3 square root of 6 minus 4 square root of 3 over all over 4 square root of 6 minus 2 square root of 3. Our denominator in here is 4 square root of 6 minus 2 square root of 3. The sign connecting the two terms of this binomial is negative. So, we have to change the negative sign Since this is negative, this has to be changed to positive. So the conjugate of the denominator is 4 square root of 6 plus 2 square root of 3. So our first step here is to, after identifying the conjugate of the denominator, is multiply both the numerator and the denominator by the conjugate of the denominator. So here we go. 3 square root of 6 minus 4 square root of 3 over 4 square root of 6 minus 2 square root of 3 times the conjugate of the denominator. We have 4 square root of 6, change the negative sign, so plus 2, copy 2 square root of 3 over the same expression, conjugate of the denominator, 4 square root of 6 plus 2 square root of 3. Now, again, we apply the FOIL method. First term, 3 square root of 6 times first term, 4 square root of 6 is 3 times 4, 12. Square root of 6 times square root of 6 is square root of 6 squared or 36. So in other words, 12 square root of 36 is the product of the first terms. 3 square root of 6 and 4 square root of 6. We go to O, the outer terms. 3 square root of 6 times positive 2 square root of 3 is positive 3 times 2, 6. Square root of 6 times 3, 18. I, inner terms, negative 4 square root of 3 times 4 square root of 6. So negative 4 times 4 is negative 16. Square root of 3 times square root of 6 is square root of 18. For the last terms, negative 4 square root of 3 times 2 square root of 3 is negative 2. 4 times 2 is negative 8. Square root of 3 times square root of 3 is square root of 9. For the denominators, we have 4 square root of 6 times 4 square root of 6. This is now the F, the first terms. So we have 4 times 4, 16. Square root of 6 times square root of 6, square root of 36. Outer terms, 4 times 2 is positive 8. Square root of 6 times square root of 3 is square root of 18. For the inner terms, negative 2 times 4 is negative 8. Square root of 3 times square root of 6 is square root of 18. The last terms, negative 2 times 2 is negative 4. Square root of 3 times square root of 3 is square root of 9. Repeat. First term times first term, we have 12. Square root of 36 here. Outer times outer term, we have 6, positive 6. Square root of 18. Inner times inner, we have negative 16. Square root of 18. Last times last, negative 8. Then square root of 9. For the denominators, first times first, 16, square root of 36. Outer times outer, positive 8, square root of 18. Inner times inner, negative 8, square root of 18, 3 times 6. And last term times last term, negative 2 times positive 2, negative 4, square root of 3 times square root of 3, square root of 9. Let us simplify. 36 is a perfect square. The square root of 36 is 6. So square root or 12 square root of 36 becomes 12 times 6. Again, 6 is taken from 36. The square root of 36 is 6. Now, we go to positive. 6 square root of 18 is 6 square root of 18 should be 9 times 2. Why choose 9? Because 9 is a perfect square. Minus 16 square root of, just like 18 here, 18, square root of 18 should be expressed as square root of 9 times 2. Then minus 8 times 9 is a perfect square. The square root of 9 is 3. So we have negative 8 times 3. Over the denominators, we have 16 times square root of 36 is 6. Plus 8, this one here, square root of 18 is 9 times 2 minus here 8 square root of 9 times 2 minus 4 times square root of 9 is 3. 12 times 6 is 72 plus 6 times the square root of 9 is 3. So we have 6 times 3 square root of 2 minus 16 times 3 square root of 2 because the square root of 9 is 3. So we have 16 times 3 minus 8 times 3 is 24 over 16 times 6 is 96. 6 times 6, 36. Okay, 96. 16 times 6. 6 times 6, 36. Bring down 6, carry 3. 1 times 6 is 6. Plus 3 is 96. So 16 times 6 is 96. Plus 8 times square root of 9 is 3. So outside the radical, square root of 2 minus 8 times the square root of 9 is 3. So 8 times 3 square root of 2 minus 4 times 3 is 12. So 72 plus 18. 6 times 3 square root of 2 radical part minus 16 times 3 is 48 radical part square root of 2 minus 24 all over 96 plus 8 times 3 is 24 square root of 2 minus, so 8 times the square root of 9 is 3, so 8 times 3 minus 8 times 3 also square root of 2 minus 4 times 12. Okay, no problem there. So we have, this is taken from this one, 8 times 3, 24 square root of 2, then 8 times 3, 24 also square root of 2 minus 12. Now there are similar terms here. For example, in the numerator, 72 and negative 24 are similar. So combine, 72 minus 24 is 48. Positive 18 square root of 2 and negative 48 square root of 2 are so similar, they can be combined. Positive 18 minus 48 is negative 30. Then copy the common radical, square root of 2 over 96 and negative 12. 96 minus 12 is 78. Oh no, I'm sorry. 6 minus 2 is 4. Then 84, no? 84 ba? 84 plus... Okay, so again, 96 minus 12 is 84. 24 square root of 2 minus 24 square root of 2. Cancel this. So 84 na. Then we try to factor. Factor. So we have... divisible by 2, 48 and 30, negative 30 square root of 2. So 2 is the common monomial factor. 48 divided by 2 is 24. Negative 30 square root of 2 divided by 2 is negative 15 square root of 2 over, we may also factor 84 into 2 times 42. Then we cancel this. So our answer is, final answer is stop. We can simplify further, no? 24 and negative 15 divisible by 3, no? 3. So we have 3 times 24 divided by 3 is 8. Negative 15 square root of 2 divided by 3 is negative 5 square root of 2. For the denominator 42, this is 3 times 14. Cancel. The final answer is 8 minus 5 square root of 2 over 14. However, PD6 atong i-factor ani. So instead of from here, yun na ba ito nimo? Instead of from here, instead of proceeding to this part, we can do otherwise. Pwede ganing na to. Pwede atong himo 46 atong LCD or common factor. 46 divided by 6, 48 divided by 6 is 8. Negative 30 square root of 2 divided by 6 is minus 5 square root of 2 over 6 times 14. 6 times 14. 6 times 14 is actually 84. 6 times 4, 24. Bring down 4, carry 2. 6 times 1 is 6 plus 2, 84. So 6 times 14 is 84. So we alternative solution siya. So after we divide out 6, ang mahibilin 8 minus 5 square root of 2 over 14 parihar jud ari. Parihar ari. So gikan diha dapita pwede mo dong taadto ngari, pwede pod ari kapaagi. Okay? So thank you so much. Hinaot na nasabtan ninyo, nakakuha mo sa akong diskusyon. Good luck. I hope nga kung mahimo kaya na dyan natin ang pagpangupya kay atong tuyo para mukat-on dili lang para makapasar kaya sa nang makapasar ta nya wata kakat-on luoy ta ining abot sa grade 10, senior high o college nya og magkamang-kamang ta sa college, chances are mahimo ta professional o makalugos o graduate, pero maglisod ta na mga exam kung na-apply ta umikan kay dili ta wa matarong atong pag-eskwela. I hope nasabtan ang akong intention ani. Thank you.